For more information, please visit SGMAK Associates website.
In this module, I'll be introducing two important concepts. One is the internal rate of return, another one is net present value. So we'll be solving problems based on IRR and then solving based on net present value. And another module I'll show for simple cash flow, these two approaches are equivalent. You can solve, they give you the same, follow the same reasoning, give you the same conclusion for a mixed simple cash flow problem. So let's look at example 1. First problem says you made annual purchase of $1,000 worth of common stock for 10 consecutive years. So you made an investment for 10 years, end of each year for $1,000. And then you did not receive any dividend from the stock. And at the end of 14 years, so made 10 purchases, $1,000 each, end of each year. Then didn't make any new investment on that for another 4 years. And at the end of 14 years, you sold the stock for $28,000. So what's the return on investment? What did you receive as return on your investment? So this, the simple way to find the IRR for simple cash flow problem is you treat the interest rate as unknown. You set up the equation for net present value and set it equal to 0 and solve for the interest rate. That's the basic idea. So you're solving this problem by moving the cash flow at the end of 14 years, moving it in terms of future value. And you set up the equivalence equation. So all the deposit you made, all the purchases you made, the future value of that is given by A times A is $1,000, your annuity purchase, A times F over A, I 10, multiplied by F over P, I 4. Cash flows are taking place end of each year. I is the interest rate, which is unknown here. That's what is the rate of return. And that's the future value of all the money that you put in. And on the right hand side of the equation is $28,000. That's what you're receiving when you sell the stock end of 14 years. So you solve this equation and you solve for I. You can treat as a net present value of this investment and setting that equal to 0. So first part, like I explained, find the equivalent single amount at the end of 10 years, and then you move it to end of 14 years. That's why you got two factors. F over A, I 10, moving your purchases to end of 10 years. You got a single sum, and then you're moving it by another 4 years to come to end of year 14. A is 1,000. So what you get the product of these two factors, F over A, I 10, and F over P, I 4 equal 28. Each one is a polynomial in terms of I. And so what you do is solve it numerically. So we just use lookup table here. For 18% I, the product of these two factors is 27.29, very close to the value we're looking for, 28. And for I equal 20%, the factor is 33.23. So our internal rate of return for this problem is somewhere between 18 and 20% and close to 18%. And for approximation, we'll do a linear interpolation. It's an approximation, and it comes out to be 18.24%. So our approximate internal rate of return in this case comes out to be 18.24%. We can call it return on investment. That's the first part. Let's look at the next example. The initial cost of a machine is $30,000. The useful life is considered to be 8 years. Annual saving is $1,000, and the machine is expected to have a salvage value, resale value of $12,000 at the end of 8 years. You are paying 8% APR on the loan. Justify whether you should purchase the equipment or not. So this is a typical decision based on net present value, and your rationale is that net present value is greater than 0. It's a good investment, and net present value you compute by finding net present value of all benefits minus the net present value of all costs. So here is the cash flow diagram. Initial expense $30,000, that's the cost. Your annual benefit of $1,000, and then your salvage value of $12,000 at the end. So net present value comes out to be, as you can see, net present value of all benefits minus all cost. 30,000 is your cost, and rest all are benefits, and you're finding the net present value of that. So you have factor A times P over A, bringing the annuity to present value, and 12,000 times P over F, bringing the future value to an equivalent present value. The net present value comes out to be $17,769.40 negative. That means your net present value of cost is more than the net present value of benefits, making the net present value less than 0. Since the net present value is less than 0, you cannot justify the purchase. You don't recover the cost. You incur a loss if you purchase the machine based on the current parameters. Let's look at the next example. Now you're comparing two alternatives, A and B, and again based on net present value. The initial cost of one alternative is $50,000, like 5 years, and salvage value $2,000. Other one has initial cost higher, same useful life, but salvage value is higher, $10,000. Using discount rate of 8% APR, we want to select which one is a better buy or better investment. The rationale is the same. You compute the net present value of both, and the one that has a higher net present value is the preferred. So net present value of the first one is present value of benefits minus the cost, comes out to be minus 48,638.8. Net present value of B, same reasoning, comes out to be minus 73,194. If we assume the cost savings are identical, because we don't have an update about cost savings, if they're identical, you will prefer alternative A, because that has a higher net present value. Okay.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.